Hey everyone, so some of you might heard of this technique before, but nonetheless, I'm going to go through the technique of standardization, when and how to perform standardization. So you might be given this question where let's say they give you an unknown mean or unknown variance. So let's say if x following a normal distribution of let's say 5 and sigma square. And you are tasked to let's say find the variance or find the value of sigma when you're given, let's say px is bigger than 6 has a probability of 0. Here will be 3. Okay, and then from here we tasked to find the sigma. What you might do is, well, you try to do inverse norm, but you don't really have a sigma square. So which means you can either use equation solver or perform standardization. So what is standardization? So coming from its name, standard, which means you're looking at the standard distribution of z following the normal distribution 0, 1, where the mean is 0 and the variance is 1, the standard deviation is 1. And the idea is that you want to go from a unknown parameter, in this case variance, to a distribution with known parameters, mean 0 and standard deviation 1. From here, how do we do it? Alright, so let me just backtrack a little and let's show you how standardization is actually done. So we begin with, let's say, a more generic example. Let's say we have x following normal distribution, mu and sigma square, and you want to end with the standard distribution of z and 0, 1. Okay, so we do this. So essentially what we need to do is just performing and changing the mean to mu to 0 and the sigma square variance to variance of 1. So we just need to apply the basic ideas. So you could choose to either settle the variance or settle the mean first. It'll be easier to settle the mean first. Alright, it's just like your translation and your scaling in your graph and transformation. First step, convert the mean. So x minus mu would then follow normal distribution 0 and you won't affect the variance. Now you want to change the variance from sigma square to 1, which means you just need to divide by sigma, because that would then cause the variance to divide by 1 over sigma square. Don't forget that when you apply, let's say kx, your variance will increase by k square. Alright, multiply by k square. Alright, so do take note of this. So we then have variance 1, and now we then have the standard distribution where we can just equate z to x minus mu sigma. So going back to the original question, we had x following normal distribution 5 sigma square, and we had px bigger than 6 equals to 0.3. So let us perform standardization so that we can get a normal distribution, or rather a variable with known parameters and distribution. So we want to get the z distribution, which means you first minus the mean. So we then have 6 minus the mean 5 over the variance is sigma equals to 0.3. Okay, so we then have 1 over sigma equals to 0.3. From here, we do the normal, which is the inverse norm, because now we have the parameters 0 for mean, 1 for standard deviation. So we can now just do inverse norm 0.3. Now in this case, for the newer GC, you have it as right. If you have the older GC, you can then use 0.7, right? Because if the normal graph where we are right now is essentially that is bigger, if you have the normal graph bigger than 1 sigma, 1 over sigma is 0.3, so this one is 0.3. Therefore, from here all the way to here must be 0.7. Right, so 0.7 left or 0.3 right will do. Now a simple way to represent this, which I'll go through in the interval method, is that we have z 0.3 equals to 1 over sigma. Then we have sigma equals to 1 over inverse norm 3, 0.3. And I won't go through the answer, you can just key into your GC. Alright, so this is standardization, and I will go through a proper example. But mainly what standardization does is that first you minus the mean. So first step is minus the mean, and then divide by the standard deviation. Alright, not divide by the variance, but divide by the standard deviation to obtain the standard distribution of z following normal 0, 1. And what you do is you then apply it on both sides in the probability here. So you apply it to here, apply it to here, you then get minus mean divided by sigma. When do you use standardization? When you need to solve an unknown mean or sigma slash sigma squared. Alright, so this is when you need to use standardization, when you solve an unknown mu or unknown sigma, or even both at the same time.